everyone, this is Kalpana here. In this video, we're going to see a problem from partial differential equation. So let's get going. Problem: form partial differential equation from z equal to y into f of x plus x into g of y by eliminating the arbitrary functions f and g. So we are asked to form a partial differential equation from this relation by eliminating this f and g, which are arbitrary functions. So let's see. Given z equal to y into f of x plus x into g of y, right? Consider it as equation number 1. Now let's partially differentiate it with respect to x. Here we are having two arbitrary functions f and g, and we are going to find p, q, r, t and also f if we feel it's necessary. Let's see. Now I'll partially differentiate it with respect to x. Partially differentiating 1 with respect to x. Okay, so you'll get dou z by dou x equal to, if we partially differentiate something with respect to x, we have to treat y as constant, right? So constant into partial derivative of f of x with respect to x is f dash of x plus constant, say g of y, into partial derivative of x with respect to x is 1, right? This gives us, since we have a notation dou z by dou x equal to p, let's replace it by notation p. We'll get p equal to y into f dash of x plus g of y. Consider it as some equation number 2. Now let's partially differentiate 1 with respect to y. Partially differentiating 1 with respect to y. Just apply dou by dou y on both sides of this equation. Since we are partially differentiating with respect to y, we have to treat x as constant. Here in the first term, we will treat f of x as constant. We will get f of x into partial derivative of y with respect to y is 1 plus treat x as constant in the second term, x into partial derivative of g of y is g dash of y, right? Also we have a notation dou z by dou y equal to q. We will replace LHS part by q. We will get q equal to f of x into 1 is f of x plus x into g dash of y. Consider as equation number 3. Now let's partially differentiate this equation 2 with respect to x. Now we need to find r. R is nothing but dou square z by dou x square, right? Or we can write this as dou by dou x of dou z by dou x. We know that dou z by dou x is p. So the partial derivative of p with respect to x gives r, right? Now what we'll do? We'll partially differentiate equation 2 with respect to x. Partially differentiating equation 2 with respect to x. We'll get dou p by dou x equal to, here we are partially differentiating with respect to x, right? So we'll treat y as constant. Constant into partial derivative of f dash of x is f double dash of x plus, here g dash of y is treated as constant since we are partially differentiating with respect to x. So we'll get equal to 0. And also we know that partial derivative of p with respect to x is r, right? This gives us, since dou p by dou x equal to r, right? We'll get r equal to y into f dash of x. Or we can write this as dou by dou x of dou z by dou x or dou square z by dou x square, which is nothing but partially differentiating this term with respect to x. Okay, dou square z by dou x square equal to y into f dash of x, f double dash of x. We know that dou square z by dou x square is r, so we'll replace it by r. This term or this term or this term can be replaced by r since it is all these three is nothing but r. So we'll get r equal to y into f double dash of x. Fine. Now we need to find t and s. Let's see that is. Okay, consider this equation as equation number 4. Okay. Now let's find t. Here t is nothing but dou square z by dou y square. Also we can write dou square z by dou y square as dou by dou y of dou z by dou y, right? Since we know that dou z by dou y is q, we can write this as dou by dou y of q or dou q by dou y. So partially differentiating q with respect to y gives t. Right, now let's partially differentiate q with respect to y. Partially differentiating q, that is equation number 3, with respect to y. Just apply dou by dou y on both sides of equation 3. Here we are partially differentiating with respect to y, so we'll treat x as constant. So partial derivative of f of x with respect to y is 0 plus constant g, okay, here x is constant, right? X into partial derivative of g dash of y with respect to y is g double dash of y. This gives us dou q by dou y equal to x into g double dash of y. We also know that this is nothing but dou by dou y of dou z by dou y, or we can write few more steps, okay, which is nothing but dou square z by dou y square. Okay, already we have, I just showed you. You can just directly write this as dou q by dou y, that is derivative of partial derivative of q with respect to y is t equal to x into g double dash of y. Okay, or you can just extend 2 more steps if you want. You can write this as dou square z by dou y square. There's nothing but, sorry, it's t, right? T equal to x into g double dash of y. Okay, you can just finish it here, or you can write these steps also. Fine. Now consider this equation as equation number 5. Let's now find s. Okay, now observe p, q and r and t, and also z. We have p y into f dash of x, g of y, q f of x plus x into g dash, r equal to y into f double dash, and t equal to x into g double dash. So I don't think all this 4 is necessary to find the required partial differential equation. So what I'll do is I'll just find s. S is nothing but dou square z by dou x dou y, right? We can write this term as dou by dou x of, that is partial derivative of dou z by dou y, or dou by dou y of dou z by dou x. Okay, which gives the same. This gives dou square z by dou x dou y, I mean dou y dou x or dou x dou y, and this gives dou square z by dou x dou y, right? So we need to find partial derivative of q with respect to x or partial derivative of p with respect to y to find s. Okay, I'll go for this one, right? And I'll show this also. Let's see. Now in order to find s, we have to partially differentiate q with respect to x or p with respect to y. I said I'll show you this, right? So I'll partially differentiate q with respect to x, that is equation 3 with respect to x. Partially differentiating 3 with respect to x. I'll just apply dou by dou x on both sides of equation 3. Since we are partially differentiating with respect to x, so we'll read y as constant. Okay, partial derivative of f of x with respect to x is f dash of x plus g dash of y is constant into partial derivative of x with respect to x is 1. This gives us f dash of x plus g dash of y. We know that partial derivative of, or you can just write this as dou q by dou x. This can be written as dou p by dou y. So partial derivative of q with respect to x is s. We'll get s equal to f dash of x plus g dash of y. You have same pattern, f dash plus g dash, right? Now we can pick it and find the general, the partial differential equation with the help of all the equations. Let's see how we are going to find it out. See, whenever we are asked to form a partial differential equation from a relation having two arbitrary functions, we need to make some rough work, okay? We have to assume something, we have to imagine something, and then we have to go for it, okay? So here I am observing all these equations. I came to know that S has f dash and g dash. So I am going to try to get the values of f dash and g dash. I am going to do now the rough work. We can also try this out. So in equation 2 I have p equal to y into f dash plus g of y. I think I can find the value of f dash of x from this. So what I'll do is I'll just bring g of y to LHS. So I'll get p minus g of y equal to y into f dash of x. Okay, fine. This is good. Now I'll bring this y to LHS so that I'll get p minus g of y by y equal to f dash of x. Finally, I got the value of f dash of x from this. F dash of x equal to p minus g of y by y. Good, right? Now, what I observe in Q is g dash of y. I need a value of, if I get a value of g dash of y, then it's good, right? So what I'll do is I'll just pick 3. From this I'll try to find the value for g dash. I have equation 3, q equal to f of x plus x into g dash of y. Okay. Now I'll bring this to LHS so that I'll get q minus f of x equal to x into g dash of y. I need the value of g dash of y. So what I'll do is I'll just bring this here. I'll get q minus f of x by x equal to g dash of y, right? So here we got the value of g dash of y, which is q minus f of x by x. Fine, right? Now let's observe s and these two. Here we can replace f dash with this value and g dash with this value, right? And we can take x y LCM. Also here we have y into f of x plus x into g of y. I think we can replace something using this z. Now I'm going to give it a try in the problem. Okay, I know this is correct. I'm writing now. I'm doing the same thing. Okay, we have equation 2, p equal to y into f dash of x plus g of y, right? Or I'll write this as, okay, which gives us y into f dash of x equal to p minus g of y, which gives us f dash of x equal to p minus g of y by y. Great. Now I'll utilize it. Fine. Now I'll go for equation 3. Already we have done in the rough work, right? I'm doing the same thing. If you want, you can just skip this part. Just move the video. Now I can also write this as f of x plus x into g dash of y equal to q. I need a value of g dash of y. So what I'll do is x into g dash of y equal to, I'll just take this to RHS, and this gives us g dash equal to q minus f by x. Okay, I'll also utilize it. Fine. Now I'll pick equation S, that is equation 6. We have equation 6, otherwise we have equation 6, S equal to f dash of x plus g dash of y, right? Which gives us S equal to, substitute the values of f dash of x and g dash of y, p minus g of y by y plus q minus f of x by x. Now find the LCM of these two. We have x, y as LCM, and here in the numerator of first term we'll have x into p minus g of y. In the numerator of second term we'll get y into q minus f of x, right, since x, y is our LCM. Now just bring this xy to LHS, we'll get sxy equal to px minus x into g of y plus qy minus y into f of x. See, we're having x into g of y minus y into f of x. We have observed that z equal to f y into f of x plus x into g of y, right? So if we can take minus common from these two terms, we can just replace the term, the resulting term, with z. So what I'll do is, I wrote these two terms first. Now I'll take minus common from these two terms, minus of y into f of x, because here y into f of x comes first, right? So I wrote this term simply, plus x into g of y, right, which gives us px plus qy minus, we can just replace it by z, since z equal to y into f of x plus x into g of y, right, which gives us, you got s xy equal to px plus qy minus z, which is the required partial differential equation. Okay, therefore sxy equal to px plus qy minus z is the required partial differential equation. Always remember that in some cases, or while finding some partial differential equation, we need to solve the equations. Okay, we need to solve by multiplying or adding or doing something. You have to do something to get partial differential equation. For that, we may use px, qy and sxy. That means we may need to multiply p with x and q with y and s with xy. Okay, and we'll apply some operations for these three to get the required partial differential equation. See, here we have px plus qy, right? Like that, we'll do something to get partial differential equation. We need to do trial and error method. It's not possible to get easy. It's not possible to find the partial differential equation easily in all cases. Okay, so we have to keep this in mind: px, qy, sxy. Fine. Okay, now I showed that s is given by partial derivative of q with respect to x, right? Now I'll show s is given by partial derivative of p with respect to y also. Okay, this completes the problem. Now I'll show you how to find s with the help of p. Just by differentiating p with respect to y, we can get s. I'll show you that now. Right? What I said, S is nothing but dou square z by dou x dou y, which is nothing but partial derivative of dou z by dou y, that is dou by dou x of p, or dou p by dou x gives S, or you can write this as dou square z by dou y dou x, right, which is multiplication. You can write dou x into dou y or dou y into dou x. You can write this term as dou by dou y of dou z by dou x, since we know that dou z by dou x is p. So partial derivative of p with respect to y also gives S. It's q, right? I'm so sorry, it's y. Dou z by dou y is q. Now I have to show this, right? So let me try. Partially differentiating p, that is equation 2, with respect to y. You can just apply dou by dou y on both sides of 2. This gives us dou p by dou y equal to, here we are partially differentiating with respect to y, so we'll treat x as constant. Here f dash of y is treated as constant. Constant into partial derivative of y with respect to y is 1, plus partial derivative of g of y is g dash of y. We know that partial derivative of y with respect to p is s. We'll get s equal to f dash of x into 1 is f dash of x plus g of y. Okay. In order to find s, either you can find partial derivative of q with respect to x. I'm writing wrong, no? You can find partial derivative of q with respect to x or partial derivative of p with respect to y. S is given by dou q by dou x or dou p by dou y. This completes the problem. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.